graphing sine function. Y equals 2 sine open bracket 3x minus pi over 6 close bracket plus 1. The sine function parent graph is y equals sine x. When we graph y equals sine x, we get this periodic function. So that's the first period of the function I've just graphed there for y equals sine x. It starts from 0 and it goes to 2 pi. That's the x-axis and that's the y-axis. This function starts from 0 goes to 2 pi. It has 3 critical points: 0, maximum, which is +1, and minimum, which is -1. And then it goes back to 0, then -1, and then 0 again. So it's divided into 4 parts. Those and that. The first part is from 0 to 90, so that's pi over 2. And then from 90 to 2 to pi, and then from pi to 3 pi over 2, and then 2 pi. And that is what we call the scale, x-axis scale, because you've divided into 4 parts. So it's easy to plot. You just go that, 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 and that. So we're going to do the same for our function. And our function there, that's what we're going to do next. We have the amplitude, so we need to find the amplitude. So that's the number one thing to do, is the amplitude. And that is the modulus of A, where A equals 2, so that would be modulus of 2 equals 2. Modulus just means the actual size. We don't want the vector size. We don't want the vector. The vector will be -2 or +2. We just want the amplitude. We just want the magnitude. So that's what the modulus is saying. Number 2 is the period. And period is basically, it's 2 pi, because the period of a parent sine, the parent sine, parent means the original sine, is 0 to 2 pi. So that's one period. That means 2 pi over 1, because there's 1, b is 1. So period is 2 pi over b. And the b, our period is going to be, because our b is 3, is going to be 2 pi over 3. And 2 pi divided by 3, 2 pi is 360 degrees. And therefore pi equals 180 degrees. So if you divide in 360 by 3, you're going to get 120 degrees. So our period is going to be 120 degrees. Unlike the sine x period is 360 degrees. Our period is going to be 120 degrees. That meant that sine x will repeat itself after every 2 pi. Our period will repeat itself after every 120 degrees rather than every 2 pi. So the next one would start from 2 pi here and it goes on to 4 pi. Ours will start from something and then goes on to 120, and then from 120 again it goes on again. So it has every 120 periodic oscillation. This has every 360 periodic oscillation. The third thing we need to do is the x scale. That's the scale here. I said it's 4 parts. So that means you always take your period, and the period here is 2 pi, so we divide it by 4 parts. That's why we go. If you divide 360 by 4, you get 90. That's why we go from 0 to 90, then 90 to 180, then 180 to 270, 270 to 360. Ours is going to go, we take our period, which is 1. So scale is period divided by 4. This only applies to sine and cosine function. So that will be 120 degrees divided by 4, and that will be 30 degrees. So for every 30 degrees is what we're going to go for. So we go from points to maximum, and then maximum to another to 0 there. So ours is going to be 30 degrees difference. That's what that is saying, because our whole period is 120 rather than 360. So we divide 120 by 4, so we go 30, 30, 30, 30. Then after the period, or we can write that in terms of the pi, and that will be pi over 6. Or sometimes you could write it as pi over 6 is also 3 pi over 18. I just times 6 by 3, and then I times the pi by 3. So that's 30 degrees. Number 4 we need to do is we need to do the start and end point. So start and end. Well, the start here we set the x to 0. That's what the start is. And then with the end we set the x to 2 pi. We don't have x, we have 3x minus pi over 6. That's what's in our bracket. The bracket here is just x. So we always set what's in the bracket to 0 at the start, and then we set what's in the bracket to 2 pi at the end. So you get 3x minus pi over 6 equal to 0, and that implies that 3x equals, so ours is minus pi over 6. Actually, let's work on with a plus pi over 6. How's that? So we just work with plus pi over 6. That makes sense. So ours is plus pi over 6. So that's plus pi over 6. So 3x plus pi over 6 equals minus pi over 6. And therefore, x will be equal to, so I need to divide both sides by 3. So that will be minus pi over 6 times 3. So that will be minus pi over 18. Because if I put 3 here, underneath here, I have to put 3 underneath here. So 6 times 3 is 18. And 3 cancel 3, and then get x. So that's the start of the angle. That's the start of the function. And pi is 180. If you divide 180 by 18, you're going to get 10. So that would be minus 10 degrees. So you could work in degrees and then later convert them to pi and pi radians if you want. So that's the start. And the end is going to be 3x plus pi over 6 equals 2 pi. And 3x will be equal to 2 pi minus pi over 6. And that's 2 pi over 1. And so that would be 3x equals 2 pi times 6. So that would be 12 pi over 6 minus pi over 6. So I've made them the same denominator. Multiply that by 6, multiply that by 6. And that would give 3x equals 11 pi over 6. Again, divide both sides by 3. So I get x equals 11 pi over 18. So all I did was divide that by, so if I divide that by 3, I have to put times 3 here because that's divide, so underneath. So 3 cancel 3, and then I've got 11 pi over 18. So that's the start. So that's important. That's the start and that's the end. One more thing, number 5 is the vertical height, vertical displacement, vertical transition. In this case, it's 1. That meant the graph is not going to lie on, this one is y equal to 0. The graph is going to lie on y equals 1, not y equal to 0. That's what that meant. So it will be raised up by 1. Okay, to sketch the function now. The graph is going to start from not 0, because this is the x-axis here. This line is the x-axis. This is the line y equals to 0. and this is a line that x equals to 0. The graph is going to start from, because it's been raised by 1, so it's going to start at y equals to 1. So this is a line y equals to 1. So that's where the graph is going to be resting on. This one is resting on the midpoint between this is y equals to 0. Because this is plus 0 here. Now what we need to do is get our points in. So the point starts at minus 10. This is minus 20, so minus 10 is here. Minus 10, and it goes, start at minus 10 here, so that's where it starts. Minus 10, that's the start. That's why we did the start point. And then it will go to, we add 30 to minus 10, so that means 10, 20, 30 to 3. Why 3? Because the amplitude is 2. So it starts at 1, and we add 2 to 1, so that's 3. So that's the maximum there, 0 to maximum. And then we then add another 30 to 20, so that will be 50. So we come down to 0 here at 50. Then we add another 30, so that will be 80. And then we come down to minus 1. Why minus 1? Well, because normally you start at 0, it would have been 2, but you're coming down by 2 from 1, because the amplitude is 2, so you have to be 1 and 2, so that's why it's minus 1. And then when you get there, it gets back to 110, because that's the end. The end is 110. How do we know it's 110? If you divide 180 by 18, you get 10. 10 times 11 is 110 degrees. So it will finishes at, or if you add 30 to 80 is 110 anyway. So it will finish back here. Do not use pen when you're sketching, use pencil. So that goes up to the maximum there. From the maximum then comes down to 0. And then from 0, it comes down to minus 1 there, the minimum. And then from there, it comes back down to 0. So this is the one oscillation. That's one period. As you can see, just like that, it's divided into 4 parts. This one too is divided into 4 parts. Minus 10 to 30 to 20, that's the first part. Then 20 to 50 is the second part. Then 50 to 80 is the third part, and 80 to 110. Just like this is by 90, 90, 90, this is by 30, 30, 30. And that's what these functions are telling us. That's what we need to do to be able to sketch it. Now we can go back to sketch the negative part of the function. So this is one period, so we could do another period to the left. So let's do that. Well, if you go minus 20, you're adding minus 30 because you're going in the negative direction. So it's going to be minus 30. You just want the size, you're just increasing it by 30. So minus 10 plus 30 will take you to 40. So it's going to go to the maximum here at 40. Its maximum is 1. So let's give it 40 there, minus 40. Then minus 40, you add another 10. So that will take you to 70. So 70 will take you back to 0 here. When I say 0, I meant on the minimum line. So that will be 70 there. And from 70 to take you to 100, because if you add 30 to 70, it will be 100. So that's minus 100 to the maximum. So that's 100 to the maximum there. And then that will take you back to 130, because if you add 30 to 100, you get 130. So this is 120, that's 130. And that's the function there. So now we can draw that pi. Just again, do not use pen when you're drawing your graph. Use pencil because you can rub it off if you make a mistake. In the exams, you haven't got time. You won't be able to rub it off if you make a mistake. But because I'm just giving you the idea here, that's why I'm using the pen. I use the pen so I can show it in colored what's happening. And so in this case, we've plotted two functions, two periods, the first period and second period. And that's what the graph is for fx. Fx is y, and that is 2 sine 3x, that's b. This one says plus pi over 6 plus 1. So if you can see, that's the function I've just written there. So that's that one plus 1. And that's how you plot that function. Let's convert these to their pi's. It's much easier to convert to their pi. Minus 10 is pi over, minus 10 is minus pi over 18. But minus 40 will be, minus, because it's 10, isn't it? Multiplied by 4. So that would be minus 4 pi over 18. So because I added 30. So minus 70 will be minus 7 pi over 18. That's just minus 7 pi over 18. Not that one. Okay, minus 100 will be minus 10 pi over 18. And minus 130 will be, which we got here, where minus 130 would be minus 13 pi over 18. Or what you could do is say minus pi over 18. Well, you're adding 30, and 30 is 3 pi over 18. So you already got minus pi, and now you're adding minus 3 pi over 18, so that will make it minus 4 pi over 18. Minus 4 pi, you add again minus 3 pi. The reason why I said minus, because you're going in the negative direction. So minus 3 pi to minus 4 pi will give you minus 7. Minus 7 will give you minus 10. Minus 10 will give you minus 13. So that's easy. So this one is minus 10 pi here over 18. Sorry, minus pi over 18. Excuse me. So that's minus pi over 18. This one here will be minus pi over 18, and you're adding 3 pi. So 3 pi plus minus pi will be 2 pi. So this is going to be 2 pi over 18. This one here will be 5 pi, because if you 2 pi, you add 3 pi over 18, that will be 5 pi. Because they have same denominator, you just add the numerator. So that will be 5 pi over 18. And this one will be, that's 8 pi over 18. And this one will be 11 pi over 18. And you can see that's where we finish, 11 pi over 18 is the end. So that's how you can convert your degrees back to pi if you had to show that. So what process do you go through? You have to go through the finding the amplitude. So that's key number 1. Make sure you recognize the amplitude so you can plot it nicely. Period is number 2, very important, because you want to show what period does it start to repeat itself. In this case, the period is 360 2 pi, because b is 1. If b was 2, you have to divide that by 2 pi by 2, so that will just be pi. In this case, b was 3, so we divide 2 pi by 3, that's 120, and that's why our period is up to 120. That length from there to there is 120. And then you do your scaling, x scale. So your x scale is, you take your period, you divide it by 4, because you know this is divided into 4 parts, so it has to go for the 0 line to the highest, back to the main point. That's the line there, main point is there, and then back to the lowest, and then back to the main point. So that happens 4 times. 1, 2, 3, 4. So that's why for sine and cosine, this only apply to sine and cosine. So it's only for sine function and cosine functions that you have to divide by 4. Take the period, divide it by 4, and then it will tell you how much you should be adding to the start till you get to the end. So you always find your start and your end. Your start is minus 10, and then your end is minus 110. So you add 30, 30, 30 until you get to minus 110. And that's what we did here. And then we do it to the negative side as well. Also do not ignore the fact that your graph is raised by 1. So it doesn't start at y equals to 0. It starts at y equals 1. So that's where it starts. And this one is y equals 0, that line. This is y equals 1. And that tells you that. It tells you it starts at y equals 1, not y equals 0. This one tells you it starts at y equals 0 because this is plus 0. So it starts at y equals 0. That one starts at y equals 0, but this one will start at y equals 1.